What exactly is a pointer in memory debugging? Imagine trying to find your keys in a cluttered room. Instead of searching everywhere, you look at a note that says exactly where they are. That note is like a pointer in programming. A pointer is a variable that stores the address of another piece of data in a computer's memory. Instead of holding the actual data, it points to where the data is stored. This makes it easier to access and change data without copying it around. In memory debugging, understanding pointers is super important because they are the main way programs manage memory. For example, if you have an integer variable, a pointer to that integer stores the memory address where that integer lives. To get the value, you need to dereference the pointer, which means using the address it holds to access the data. Think of dereferencing as opening the door to the room where the data is kept. Pointers are especially useful in languages like C and C++ because they give programmers control over memory. They help with dynamic memory allocation, which means creating memory on the fly and managing complex data structures like linked lists and trees. But with this power comes responsibility. If you misuse pointers, problems can happen. One common issue is a dangling pointer. This is when a pointer still holds the address of memory that has been freed or deallocated. If you try to access that memory, your program can crash or behave unpredictably. Memory leaks happen when you allocate memory but forget to free it afterward, wasting resources. Buffer overruns are when a pointer moves outside the bounds of allocated memory, possibly overwriting important data. Invalid pointer dereferencing occurs when a pointer points to a location that isn't valid, causing crashes or strange bugs. Memory debugging tools track how pointers are used, helping you find these issues. They can check if a pointer points to valid memory before you access it. For example, some tools keep track of all memory allocations and deallocations, making it easier to spot leaks or invalid accesses. Advanced debuggers can even show you the value of a pointer and the memory it points to, so you can see if it's correct. Getting good at managing pointers in debugging means knowing how they store addresses and how to dereference them safely. You need to recognize common bugs like dangling pointers and buffer overruns. Using debugging tools to inspect pointer values and the memory they reference is key. Always verify that a pointer points to valid, allocated memory before you use it. Tracking memory allocation and deallocation helps prevent leaks and invalid memory access. In short, a pointer in memory debugging is a variable that holds a memory address, allowing indirect access to data. Managing pointers carefully is essential to catching and fixing bugs like dangling pointers and buffer overruns, which are frequent challenges in software development.